This video is part 5 of Competency 17, which relates to probability. In this video, we review the geometcdf on our TI-84 calculator. Okay, before we begin, we need to remember that we are looking for successes and failures. Number 1, suppose it's known that 4% of individuals who visit a museum will sign up for membership. What is the probability that less than 9 people will enter the museum before one of them will sign up for a membership? Well, let's think about this. We have 9 people. Well, we're saying less than 9 come in first, and all these people are failures until finally we have a success on the 9th person. Okay, that's really what this means. You may have to think about that for a minute. So when we're using our geometcdf and we're talking about all the numbers below a value, we have to include everything. So in our TI-84, this looks like second bars alpha tan. Our probability is 0.04 for 4%. Enter. We need all 9 people because our 9th one is our success. And do we have one? Let's change this. Yes, with rounding, that would be option D. Okay. Suppose it's known that 4% of the individuals who visit a museum will sign up for membership. What is the probability that more than 9 people will enter the museum before one of them will sign up for membership? Okay, in this case, we're going to have to subtract out all of these people because we said more. So what does that look like? We have to say let me state this again. What we're really doing is we're saying that, hey, we're taking all of these probabilities out of our total of 1. Remember, all your probabilities add up to equal 1. So we're taking out these lower trials to get the upper ones, basically is what you could say. So 1 minus second bars alpha tan. Okay, we have 4, 4, 4, and we are taking out the 9, and that gives us option C. Okay. Oh, that's funny. Let me try that one more time and see if it creates our circle. Number 3, suppose a couple has decided to have children and are hoping for both boys and girls. What is the probability that the first son born is at most the 4th child? Okay, in this scenario, we're looking at a 50-50 chance of having a boy or a girl, and we need to consider all those, let's say, chances or trials. Okay, so that would be an ordinary CDF, or let's just say a general geometric CDF. Okay, so second bars alpha tan, and our percent is 1 out of 2, and we need enter. We're talking about all 4. We want 1 to 4. Enter, and our option is A. Okay. Number 4, using the same couple from number 2, what is the probability that the first son born is at least the 3rd child? Okay, in this situation, we need to take out the probabilities for the first and second And then we're really focusing on the third child and say they have more kids, okay? Okay. Oh, that's kind of, okay, there we go. All right. So we need to start with 1 minus second bars, then alpha tan. We still have that half percentage, but this time we are excluding up to 2 and inner, and that would be 25% chance of having a boy at that point. Number 5, let's go down. Number 5, an instructor feels that 15% of the students earn below a C on the final exam. She selects and reviews a final exam and replaces them in the pile until she finds one below a C average. What is the probability that the instructor will examine at least 10 exams until she finds one with a grade below a C? So there's our percentage. Okay, what is really going on? What do we need to exclude? We have to exclude because we have the words at least. Well, we know that means we need at least or more. So we're going to increase. Oh, goodness, may need to turn that off. Let's see. Well, we need 10 or more, so it will go up, right? Then we exclude 1 to 9. Let's put that in the calculator. 1 minus second bars alpha tan, and we're talking about 15%, enter, and we are excluding 1 to 9, so we're going to have to put in 9 and enter, and that gives us A. Number 6, according to the AVMA, that is the Veterinary Association, 30.4% of U.S. households own one or more cats. Suppose you randomly select some households. How likely is it that your first cat owner household will be somewhere in the first 5 you survey? Okay. This means that we need to include all of the households from 1 to 5. So that will be second bars, alpha tan, and our percentage is 0.304. Turn that into a decimal. Enter how many households. We're going to look at all of the 5. Enter, and that is, oh, that's a rounded A. Okay. Number 7. You draw cards from a deck, then replace it. A card from a deck, and then you replace it and shuffle the deck until you get a heart. What is the probability of drawing a heart on at least the 20th try? Well, that means that you are going to exclude 1 to 19. We want him, 19, not 10. We want to exclude 1 to 19 or subtract them out of that total probability that equals 1. Okay, so that means, and we want our 20th and up. So 1 minus second bars alpha tan, and our probability of drawing a heart. So we want a heart. That is 13 out of 52. Enter. So it's the first 19 that we're going to subtract out. Enter, enter, and that's option C. Number 8, an instructor believes that 15% of the students earned below a C average on the final exam. She reviews a final exam from a pile of exams, then replaces the exam until she finds one below a C average. What is the probability that the instructor will examine less than 10 exams before finding one with a grade below a C? All right, this is why we use that geometric CDF, okay? Because we don't want exactly 10 exams. We're not saying on the 10, but we have a range from 1 to 9. Okay, whenever this happens, and you know you have a range from 1 to 9, and there is replacement, you can use that. Okay, just as we did before. So second vars go up, and that's what we need. So press enter. Well, I have 15%, but there's 10 in there from a prior question. So we need to type over that and put in 9, okay? And then enter, enter, enter again. And there you go, number C. Okay, this is the last question in this video. Wanted to thank you guys for watching and liking and subscribing and definitely sharing. Sharing has really helped. And I wish everyone the best. Happy testing.